Okay, so we'll start at the top and then we'll see how you did on this one. Order of operations, PEMDAS. Please excuse my dear Aunt Sally. So the P is parentheses, which is definitely first, and then exponents. Multiplication and division is a tie, so they come next, and then addition, subtraction is a tie, so they come next, and you always work left to right. When multiplying like bases, for instance, x to the third times x to the fourth times x squared, what do you do to the exponents? You add them. And so this would be x to the ninth right there. Okay. When you have a power to a power, for instance, like that, what do you do to the exponents? You multiply them. Okay. So what exactly does 4 to the 8th mean? Yeah, 4 times 4 times 4 times 4, 8 times. And is it different than 8 to the 4th? Yes, 8 to the 4th is 8 times 8 times 8 times 8. Okay, very different, very different. Okay, so let's see how we did. Number 11. Anyone want to tell me what you got? Okay, I'm right. There's going to be different answers. Okay, so I hear 8. I hear 6.5. 6. 6 point what? Anything different than these three? 4. Anything different than these 4? You're stressed out. Don't stress out. Okay, one of these is correct. So you see this like on Facebook and junk like that all the time, of like, oh, here's this problem, and then you see like 80,000 responses of grown adults getting it like all different answers, and you're like, how can people be getting the wrong answers? And it's order of operations. It's just hard. People think, oh, it's easy. You learn it when you're very young. No, it's hard. All right, so 3 plus, okay, so I have parentheses right here. So I'm going to do that one first. So I'm very careful on these. I just rewrite everything I'm not doing sometimes. And right there, I'll do that first. 3 plus 3 is 6. Okay. So there are no exponents. I did parentheses. So now I'm on the multiplication division. So I look here, and that's a little multiplication division going on. That's a little division going on. So I'm just going to write 3 plus, and going left to right, I have 3 divided by 3 is 1 times 3. 3 divided by 6 is 1/2. So I have 3 plus 3 plus half, which is 6 1/2. Yes? No, yes, no. Okay, this one's going to be, anyone have a question on that one? This one's going to be even more dramatic. Okay, number 12. Somebody tell me what you got. Don't be shy. There's going to be at least 5, 6, 7 answers. What'd you get? Negative 159. Someone else. You had to have gotten something. Oh, well, let me give you a few more minutes. I'm going to pause this. You finish. All right, so a negative 1 to an odd power stays negative. So I'm just going to write -1, and I'm just going to write these others out because I'm just doing parentheses at the moment in exponents. And then over here, negative 5 to the third would be negative 5 times negative 5 times negative 5, which is negative 125. So on that step, I got rid of my exponents and parentheses. So now I have addition, subtraction, addition, subtraction, addition, subtraction, multiply, divide, multiply, and then subtraction. So I'm going to focus on the multiply, divide, multiply going on here. So reading from left to right. Over here I have negative 6 minus 64 minus 1 times 48 is 48. I think we can do that part in our head. So then 48 divided by negative 4 is 12. And I'm just going to write times 3 minus 125. So now I have one more multiplying going on. So negative 6 minus 64 minus 36 minus 125. And now I'm to the addition subtraction part. So I can just type all this in my calculator if I want, or add it up if I want. Negative 64 and negative 36. 64 and 36 are nice Pythagorean numbers. They always add to 100. So that's negative 100. Did I do that right? Where did we get that from? Oh, yes, you're right. So forget that idea. All right, so this would be negative 70, negative 195 plus 36, negative 159. Yes? Okay. So order of operations, there will be one of these, like those two right there, on your test, whenever our test is, which is a ways away. These other kind are slightly different. So we have negative 2 to the 64 power. What does that mean? But what does it actually mean? Negative 2 times negative 2 times negative 2 times negative 2 times negative 2, 64 times. He didn't like that. Going back over here. Okay, but, and then 2 to the 64 is 2 times 2 times 2 times 2, 64 times. But we also know that negative to the 64 power will become a positive number. It's the exact same positive number as you'd get if you did 2 to the 64 power. So I'll just rewrite it. So I have 2 to the 64 minus 2 to the 64, which is what? 0. Okay. This is going to seem a little weird. So I have a negative 2 to the 63, but the negative's not being raised to the 63, right? And then plus 2 to the 64. So this is 2 times 2 times 2 times 2, 63 times. And this is 2 times 2 times 2 times 2 times 2, 64 times. Since it's not being raised to power, I'm going to swap these and make it look like a subtraction problem. Just for simplicity's sake. What law is that? Commutative. The commutative property. All right. And so to subtract these, I'm going to pull out the biggest thing I can out of both numbers. So this is 2 times 2 times 2, 64 times. And this is 2 times itself 63 times. How many 2's can I pull out? 63. I can pull 63 of them out of both. And so I'm going to just factor it out of both. So I've got 2 to the 63. On the first part right here, it leaves me with a 2 minus. On the second part here, I pulled out all the 2's, so it leaves me with a placeholder. So this is where some people get confused and want to put 0 there, but think if we wanted to multiply it back through. 2 to the 63 times 2 to the 1 is 2 to the 64. 2 to the 63 times 1 is 2 to the 63. And so then what's 2 minus 1? 1. So this is 2 to the 63. Because it's 2 times 2 times 2 times 2, 64 times. Which is a ginormous number. I'm not just taking away 2, though. Hang with me. Okay, so on example 15, I have a negative 2 to the 8. Is the negative being raised to the 8? So it makes it what? Positive. So this is the same thing as positive 2 to the 8 plus positive 2 to the 8. Correct? Okay, so I want to add these. So I'm going to show you 2 different ways to think about this. One way is to do what we just did. So right here we have 2 times 2 times 2 times 2 times 2 times 2, 8 times, plus 2 times 2 times 2 times 2 times 2 times 2, 8 times. So the most 2's I could pull out of both is how many? 8. So I could factor that out of both of them, and it would leave me with a placeholder plus a placeholder, because I was able to take all of them out, right? And so then I have 2 to the 8th. What's 1 plus 1? 2. And what's 2 to the 8th times 2 to the 1? 2 to the 9th. So let me show you a different way to look at that. You could also think like I'm adding 2 to the 8th to itself how many times? So if we did like, I'm adding 4 to itself how many times? 5. So I could just do 4 times 5. Okay, so I'm adding 2 to the 8th to itself 2 times. So I could just do 2 times 2 to the 8th, which would be 2 to the 9th. All right. So here, is the negative being raised on this one? No. So it stays negative. So I could swap these if I want and think of it as 2 to the 8th minus 2 to the 8th, which is what? 0. Okay, I'm going to try to make up one real quick, which is never good for me. Dang it. I gave Miss Carter the wrong quiz to go copy for me. That's okay. All right. I'm really bad at making up problems. Bear with me. So we're going to add 3 to the 200 plus 3 to the 200 plus 3 to the 199. So I'm going to have, what's the most 3's I could take out of those? 3 to the 199. And that's going to leave me with, right here it leaves me with 1 3 left over. Here it leaves me with a 3 left over. And here I took it all out, so it just leaves me with a place value holder, right? And so I have 3 to the 199 times 7. All right. What's that? No, you can't multiply the 3 and 7 because 3 is being raised to the 199. Okay. We're actually doing this to prepare for a different section here. All right. So moving on. Okay, so we have this definition of divisibility. So the definition, B divides A. B divides A. If A and B are any integers, then B divides A, and this is how you write it, a straight up and down line. B divides A. If and only if, that means it goes both ways, there is a unique integer Q such that A equals B times Q. So let me write this out for you better. So B divides A implies that A equals B times Q, where Q is a unique integer. And I'm going to back to my video. So I want to point out some notation here that people have trouble with. So we can say A divided by B is the same thing as A divided by B, yes. Which is the same thing as A divided by B, yes. Which is the same thing, get ready for this, as B divides A. Yes, yes. This is our new definition. So this reads divides. B divides A. So this all means divided by, divided by, divided by. This means divides into. Not divided by, but divides into. So let me put some numbers with it for you for a second. So we could do 12 divided by 4. That's a perfect little division problem, which is the same as 12 divided by 4, which is the same as 12 divided by 4, which is the same thing as 4 divides 12. Okay? It's called divides. So let's look at some of these. So it says classify each of the following as true or false. So this says negative 3 divides 12. So I'm going to refer to our definition for divides. Negative 3 divides 12 would imply, if it were true, it would imply that 12 equals negative 3 times Q, where Q is a unique integer. Is there a unique integer Q that makes that true? Yes. What is it? -4. So this is true. All right. 0 divides 2. If it's true, that implies that 2 equals 0 times q, where q is a unique integer. Is there a unique integer q that makes this true? No. This is false. Anybody remember what this is called? There is no value of q that would ever make this true. There's nothing you can multiply to 0 to give you 2. So it's undefined. There's no q in definition in existence. 0 is even. If 0 is even, what makes a number even? It's divisible by 2. So 0 is even means we could do 0 divided by 2, which would imply that 2 divides 0, which would imply that 0 equals 2 times q, where q is a unique integer. Is there a unique integer q that makes this true? Yes, 0. All right. 8 divides 2. 8 divides 2 is written like this, and it would imply that 2 equals 8 times q, where q is a unique integer. Is there a unique integer q to make this true? No. There's a rational number, 1/4, that makes this true, but not an integer. Okay. For all integers a, 1 divides a. If 1 divides a, that implies that a equals 1 times q, where q is a unique integer. Is there a unique integer q that makes this true? Yes, a. Okay. -1 divides a implies that a would equal -1 times q, where q is a unique integer. Is there a unique integer q that would make this true? -a. 3 divides 6n for all integers n would imply that 6n equals 3 times q, where q is a unique integer. Is there a unique integer q that would make this true? 2n. So yes, aka true. 0 divides 0 implies that 0 equals 0 times q, where q is a unique integer. Is there a unique integer q to make this true? Explain. Any integer would make this true, not a unique one. What's this called? Indeterminate. Okay. So if I try to describe these with A and B, they get a little confusing, so I'm going to stick actual numbers in here. But divisible, divisor, multiple, factor, divides, we're going to talk about that. A divisor and a factor are the exact same thing. Divisor and factor are the exact same thing. So, Laura, give me 2 numbers that are divisible by each other. Be a little more creative. Okay, we'll go with that. So I have 10 and I have 100. If I say one of these is A and one of these is B, such that A is divisible by B, which one's A and which one's B? 100. So A would be 100 and B would be 10. So we could say A is divisible by B. 100 is divisible by 10. Yes? Okay. We could say 10 is a divisor of 100, a factor of 100. Yes, 10 times 10 gives you 100. So then we could say 100 is a multiple of 10. Yes? 10 times 10. It's a multiple. And we'd say 10 is a factor of 100. That's the same thing as divisor, factor, divisor. And then 10 divides 100 because I'll write that one out. So 10 divides 100 implies that 100 equals 10 times q, where q is a unique integer, aka q is 10. Okay. So go on the next page. See if you fill in the words that go in example 2 here. Okay. Fill in the blank with one of the following words. Factor, divisor, those mean the same thing. Multiple or divides. Okay. Y'all ready? Okay. Ms. Martinez, part A. 5 is a blank of 100. Oh, wait, and let's stop a second. Let me pause this. All right, so 5 is a blank of 100, Ms. Martinez. What is it? A factor. Mm-hmm. We're doing good. Oh.
Seriously, like, keep going.
Okay, we're doing good. Taylor, 60 is a blank of 3.
60 is
You got a choice of 3 things.
Yeah.
Oops. Okay, get back to your texting. We'll come back to you.
Well, but can I tell you why?
No.
It'll be more fun.
Okay, 60 is a blank of 3. Hannah, 60 is a what of 3? Awesome. And multiple just means you can multiply something to 3 that'll give you 60. 3 times 20. If x is an element of the whole numbers, then 7x is a blank of x. What is it? 7 times x, 7 multiplied to x. Since 4 is a blank of 20, then 4 blank 20. Help me here. Divisor or factor of 20. If 4 is a divisor or factor of 20, then 4 blank 20 divides. Okay. We got that. Okay, so this looks crazy, but let me tell you, you already know half of these. So these are divisibility rules. There's divisibility rules for the digits 2 through 11 except for 7. And these are the rules, but you already know a lot of them. For instance, a number is divisible by 10 if what? The last digit is 0. A number is divisible by 5 if what? If the last digit is a 5 or a 0. Y'all know this, right? A number is divisible by 2 if what? If the last digit is a, okay. We'll look at those. A number is divisible by 2 if the last digit is divisible by 2. So 168 is divisible by 2 because 8 is divisible by 2. It's an even number. For 5, a number is divisible by 5 if the last digit is divisible by 5. In other words, if it's a 0 or a 5. So this is divisible by 5 because the last digit is a 0 or 5. Number is divisible by 10 if the last digit is 0. That's divisible by 10 because the last digit is 0. So we already know all those. Yes? Okay. So then the rule for divisibility by 3, which you may have looked because of the project, the sum of the digits, if the sum of the digits is divisible by 3, the whole number is divisible by 3. So if we wanted to know if 168 is divisible by 3, 1 plus 6 plus 8 is 15. 15 is divisible by 3, so 168 is also divisible by 3. Y'all with me on that? Okay. That's the exact same rule for 9. A number is divisible by 9 if the sum of the digits is divisible by 9. So back up here, 168, is that divisible by 9? No, because 15 is not divisible by 9. But 549, 5 plus 4 plus 9 is 18. That's divisible by 9. So 549 is also divisible by 9. Okay? So same rule for 3 and 9. Then our rule for 4 is kind of similar to 2. For 2, the last digit had to be divisible by 2. It had to be even. For 4, the last 2 digits have to be divisible by 4. So 316 is divisible by 4 because 16 is divisible by 4. So if I had this number, is this number divisible by 4?
Yes.
Why?
Because the last 2 digits.
Because those last 2 digits are divisible by 4. So this whole number is divisible by 4. Yeah? Okay. Same kind of a rule for 8, except it's the last 3 digits now. Because 2 times 2 times 2, that's 3 2s. So if the last 3 digits are divisible by 8, then the entire thing is divisible by 8. So since 120 is divisible by 8, this whole number is divisible by 8. So let me ask this question. This big number I just wrote out on the board, if we want to know, is it divisible by 8, then we need to know, is 628 divisible by 8 with no remainder? You can use your calculator, but I'll just do it by hand. So that'd be 7, that's 56, 6, 8, 8 goes into 68. So no, because there's a remainder of 4. So this whole number is not divisible by 8 because the last 3 digits are not divisible by 8. You with me? Okay. A number is divisible by 6 if it's divisible by 2 and 3. Yeah? Okay. That's going to cover all of them except 11, which is really weird. Hang with me. Okay, so if I had a decimal spot, come up here. If I had a decimal right here, and these spots are going on, so this is my ones place, which is the 10 to the zeros place, and then my tens place, which is 10 to the 1, my hundreds, which is 10 squared, 10 cubed, 10 fourth. Okay, so 0 is an even power. 1 is an odd power, 2 is an even power, 3 is an odd power, 4 is an even power, right? Okay. So it says, if the sum of the digits in the places of, what's the sum mean? Addition. If the sum of the digits in the places of even powers of 10 minus the sum of the digits of the places that are odd powers of 10 is divisible by 11, then the whole number is divisible by 11. So first, before we even look at that, what numbers are divisible by 11? Somebody give me a number that's divisible by 11. 22. 22 divided by 11 is 2. That's great. What else? 44. 44 divided by 11 is 4. Go down. Go down. Lower than 22. 11. 11 divided by 11 is 1. So that works. Can you go lower than 11? 0. 0 divided by 11 is 0, so that works. So far we've said these all work, right? What about negative 11? Does that work? Yep. What about negative 22? Yep. Okay, are y'all with me? These are numbers that are divisible by 11. All right, so I showed you right here. This number is divisible by 11 because I'm going to add 9 plus 8 plus 9, because this is in the 10 to the 0 spot, the 10 squared spot, and the 10 to the 4th spot. So the 10 to the even powered spots. Minus 2 plus 1 plus 1, which are all in odd powered spots. 10 to the 1, 10 to the 3, 10 to the 5. And so if I add 9 plus 8 plus 9 minus 2 plus 1 plus 1, I get 22. 22 is divisible by 11, so this whole number is divisible by 11. Okay? Okay, we're going to talk through this one as a group. We want to check, is 5,280 divisible, blah, blah, blah. So is this number divisible by 2?
Yes.
How come? Because it ends in an even number. Is it divisible by 3? How come? Because 5 plus 2 plus 8 plus 0 equals 15. And since 15 is divisible by 3, the whole thing's divisible by 3, right, Catherine? Whole thing? Okay. So would this whole thing be divisible by 9? No. How come? It's the same rule. The sum of the digits is 15. 15 is not divisible by 9, so this whole thing is not divisible by 9. Is it divisible by 4? Yes. How come? Because 80 is divisible by 4. Is it divisible by 5? How come? Because the last digit is either a 5 or a 0. Is it divisible by 6? Yes. How come? because it's divisible by 2 and 3. Is it divisible by 8? Well, you'd have to check 280 to see. So if I divide it by 8, I can go in there 3 times. And again, you can use your calculator. And then 5 times, and that's perfect. So yes, it is divisible by 8 because 280 is divisible by 8. Is it divisible by 10? Yes. Why? The last digit ends in last digit is a 0. And then to see if it's divisible by 11, we add 0 plus 2, which are in the even spots, minus 8 plus 5. So we get 2 minus 13, which is negative 11. So is it divisible by 11? Yes. All right. Y'all ready? Because this is your challenge. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, you ready? I'm going to tell you which problem you're doing. 1, 2, 3, 4, 5, 6, 7, 8. Okay, yeah. First 2 rows, y'all are doing A. So you're doing A, you're doing A, y'all are doing A. 1, 2, 3, 4, 5. Y'all are doing A. 6, 7. Y'all are all doing B, and you're doing B. 1, 2, 3, 4, 5, 6, 7, 8, 9. Y'all are all doing C. I'm lying. Yeah, no, y'all are doing C. Okay, I'm going to give you maybe 3-4 minutes. Okay, it says list all digits, if any, that can go in the blank of this number here. And so right there, in order for it to be divisible by 2. So what makes a number divisible by 2? The last digit has to be divisible by 2. So which digits could we put in that blank there for this whole number to be divisible by 2? How many digits are there? 10. So we could do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Any of them. And it'll still be divisible by 2. Okay. And then to be divisible by 3, the sum of the digits has to be. So I'm going to say 5 plus 2 plus 7 plus 4 plus question mark plus 2 gives me what does it give me? 14, 15, 16, 17, 18, 19, 20 plus question mark? Are y'all with me? Okay. So if I put the digit 0 in there, I'd have 20 plus 0. Is that divisible by 3? No. What if I put a 1 in there? Yes. So a 1 would work. What if I put a 2 in there? If I put a 3 in there? If I put a 4 in there? Yes, because 20 plus 4 is 24, and 24 is divisible by 3. What if I put a 5 in there? 6, 7? Yes, because 27 is divisible by 3. 8, 9? No. While we're on the sum of the digits, what else should we just go ahead and do? 9, because it's the same rule. So, same rule, I'm just going to skip to here. I have 20 plus question mark. If I put a 0 in there, is that divisible by 9? No. 1, 2, 3, 4, 5. Oh, 24? No. 5, 26, 27. Yay. 28, 29. All right. Question on what we're doing right here? Talk to me. Okay, so I did the sum of the digits is 20 plus question mark, whatever that is. And it needs to be, the sum needs to be divisible by 3. So I just said if I did 20, 21, 22, 23, and these 4 worked. These 3 worked. Then I did the same thing for 9. And the only one that will work is if I did 20 plus 7. 27 is divisible by 9. You with me? Yes, yes you are. Okay. To be divisible by 4, what has to happen? These last 2 digits have to be divisible by 4. So if I put a 0 in there and got 0, 2, which is 2, is that divisible by 4? No. If I put a 1 in there, is 12 divisible by 4? Yes. If I put a 2 in there and got 22? No. 32? So I could put a 3. 42? 52? Yes. 62 divisible by 4? 72 divisible by 4? 82? Nope. 92? Yeah. And then I want to see what do I need to put in there for this number to be divisible by 11. So I'm going to add, I'll highlight it for you. Boom, 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 and boom, boom, boom. Okay. So I'm going to have 2 plus 4 plus 2 minus question mark plus 7 plus 5. Are y'all with me on that part? Okay. So I added the ones in yellow. Don't do that. Undo. So I added these ones in yellow and I subtracted the ones in blue. And so then I get 2 plus 4 plus 2 is 8 minus parentheses question mark plus 12. Yes? I'm going to distribute my negative. 8 minus question mark minus 12. I can combine the 8 and the negative 12. So I have negative 4 minus question mark. And I need this to be divisible by 11 in order for the whole number to be divisible by 11. If I put a 0 in there, negative 4 minus 0 is negative 4. Is that divisible by 11? Nope. If I put a 1 in there, I'd get negative 5. Is that divisible by 11? If I put a 2 in there, I'd get negative 6. Is that divisible by 11? What do I need to put in there? A 7. Because negative 4 minus 7 is negative 11, which is divisible by 11. All right.